Welcome to SimplyGIS, GIS for everyone.
Hello everyone, welcome to SimplyGIS YouTube channel. In this video, I will demonstrate how to calculate NDWI and MNDWI in QGIS software. NDWI or Normalized Difference Water Index is a common spectral index mainly used for delineating and mapping water surfaces in any area. The core concept of NDWI and MNDWI is that water surfaces reflect blue wavelength and absorb green, red, and near infrared and shortwave infrared wavelengths of EMR. Using this concept, we compare the band ratios of near infrared and shortwave infrared bands and calculate the NDWI. And the modified normalized difference water index or MNDWI is another advanced spectral index for this same process of delineating water surface, and it generally use band ratio of green and shortwave infrared bands. The result for NDWI and MNDWI ranges between -1 and +1. Here, the positive values indicate water surfaces, whereas the negative values refer to the soil, vegetation, and other surface features. Overall, using NDWI and MNDWI, we can delineate the water surface in any area. In this video, I will show how to first create NDWI and MNDWI maps using Landsat band 3, band 5, and band 6. So I have imported band 6, which is shortwave infrared for my study area, then near infrared band 5 and band 3, which is green band. To calculate NDWI, we need near infrared and shortwave infrared bands. So let's go to raster calculator and write the formula. I'm putting a bracket near infrared minus shortwave infrared bracket close divided by again bracket start near infrared plus shortwave infrared bracket close. My expression is valid. Now I want to save this in a destined folder. You can see here output layer. I'm clicking here. So I'm going to the folder where I want to save it. Indices ndwi.tif save. Okay. I have set the output layer where I want to save the ndwi and my expression is valid. Formula is correctly written. Clicking OK. So here is the NDWI of my study area. Now I want to visualize this NDWI. For that, let's go to the layer, right click and go to properties. And in properties, there is a symbology. In symbology, there is a render type where I will select single band pseudo color. And in the color ramp, I will select blues, where the lowest value is in the white and the highest value is in the blue. Let's apply it. Okay. So you can see this is the NDWI of my study area where NIR and shortwave infrared bands have been used. As a result, I can delineate the water bodies. You can see here is the water bodies as well as the areas where the soil moisture and vegetation is higher. So there are also the water reflectance has come out. So you can see the value is ranging from minus 0.172 plus 0.28, where the positive values are the water surfaces. I will extract the water surfaces. For that reason, I will go to raster calculator. Then I will type in the calculation express NDWI greater than or is equal to 0. Then I will save it to the output layer destination NDWI water.tif. Let's save it. Okay, run it. I'm again visualizing this. Let's go to the properties, symbology, single band pseudo color, blue, keep it The render type should be blue and apply it. Okay, so you can see these are the water surface areas according to NDWI, where you can see the water bodies are also marked, as well as some areas, some land and vegetation areas where the water surfaces are visible. So to overcome this problem, modified normalized water index was introduced. Now I will calculate the MNDWI. As I told you, for MNDWI, we need shortwave and green bands. So I'm going to again going to raster calculator, then typing the formula bracket green minus shortwave infrared bracket close divided by bracket start green plus shortwave infrared bracket close. My expression is valid. I am saving this to desired folder and naming it mndwi.tif. Okay, save it and now click OK. So you can see my MNDWI is also ready, where the values are ranging from minus 0.32 plus 0.14, where as I told you the positive values are the water surfaces. Let's visualize this. I'm going to the layer, right click, properties, symbology, render type single band pseudo color, and in the color ramp I will select the blues and apply it. Okay. So you can see here is my MNDWI, which is far better than the NDWI I have already created. So again, I will extract the water surfaces. As I told you, the positive values indicate the water surfaces. So I am extracting using the raster calculator. Raster calculator, and I am writing MNDWI greater than or is equal to 0 and saving it as a MNDWI underscore water dot tif. Save. Okay. Now you can see my water surfaces according to MNDWI has been calculated. Again, I am visualizing it. Right click, properties, symbology, render type single band pseudo color, and the color ramp I am choosing the blues and apply it. Okay. So you can see the the water surface areas are easily detectable in MNDWI. That is the significance of MNDWI. It gives you more accurate result. So if you want to map water surface extent in your study area, MNDWI is the best solution to you. And in this way, you can create both NDWI and MNDWI for your study area. If you like the demonstration, you can support us by liking the video, sharing the video, and subscribing to our channel. Thank you. SimplyGIS is offering 6 months course on basic of remote sensing and GIS. You can visit our website simplygis.in and check details about the course. It is a 6-month course. The classes will be held online on Saturday and Sunday. The time is flexible. Here is the registration form. You can click and register yourself. This is the detailed course structure. For more videos on remote sensing and GIS and tutorials of QGIS and ArcMap, please subscribe our channel SimplyGIS and also click on the notification icon. There are playlists on QGIS and ArcMap. You can check them.